Okay. I did an example and there was an error, and instead of keep recording, I just thought I'd start over. So just ignore that. Okay. So here you're given a quartic. That means it's going to cross, theoretically, the x-axis 4 times. Okay, so it means we should have 4 zeros. You take factors of your constant and put them over factors of your leading coefficient to find possibilities. There could be more or less, but this is just going to give you, it's going to hone in your search. So you could have chosen 6 or -6, 3 or -3, 2 or -2, 1 or -1. If we try 1, we get 1 minus 1, 0, plus 1, 1, minus 3, -2. It's not going to work. I discovered that -1 does work. Now, you could just substitute that -1 into check, or you could have used synthetic division and saw that it does work, or see that it does work. 1, -1, 1, -3, and -6 are your coefficients. You're going to drop 1, get -2, +2, 3, -3, -6, +6. Okay. So we are left with, we're 1 degree down, x cubed, but I like to go backwards just in case I messed it up. Yes, it is x cubed. So I am left with x cubed minus 2x squared minus 3x minus 6. Okay. You can keep going and using the rational root theorem, but if you have an easier way to factor, go ahead and do that. I have 4 terms. Something tells me that I could use grouping. Between these two, I share an x squared, and I'm left with an x minus 2. Between these two, I think that's actually positive. Between these two, I share a 3, and I'm left with an x minus 2. If I did not see an x minus 2 twice, then this method would not be beneficial to me. So between the two, x minus 2, and then an x squared plus 3. So my remaining factors are an x minus 2, which gives me a solution of 2, or an intercept, and then x squared plus 3. I can't factor this, okay? But I can set it equal to 0 and solve and figure out what my solution would be. When I take the square root of both sides, I'm going to get x equals a positive I root 3 and a negative I root 3. So I physically cross the x-axis at these 2 points. This theorem only covers the rational. Okay, the theorem does not help you find complex solutions, but using division and factoring, you can find the complex solutions. So I actually cross at 2 places. These 2 are complex solutions. They won't graphically work, but algebraically they will. Okay. Last example, I should have 4 zeros again. And I have factors of 8 over 1. So it could have been 8 or -8. It could be 4 or -4, 2 or -2, 1 or -1. When I substitute 1 in, that's not going to work. There are pluses. So none of these pluses are going to work, or positives, I should say. The negatives, they should work. So maybe it's -1. -1, -10. So +1, -10. +33, -38. All right, let's try it. 1, -10, +33, -38, +8. All right, so -48 and a 41. Nope, that's not going to work. All right, what if we tried 2? -2. So -2 to the 4th plus 10, -2 cubed. Oh, goodness. Yep, it worked. So -2 works. So a factor is x plus 2. And we're going to use synthetic division. 1, 10, 33, 38, and 8. Drop 1, negative 2, we get 8, negative 16, we get 17. Negative 2 times 17 is negative 34, we get 4, negative 8, 0. All right, we're down a degree. So now we have x cubed plus 8x plus 17x plus 4. Oh boy, we can't use grouping here. I can tell right away that we're not going to get the same thing twice. So what are we going to have to use again? Rational root. So we have factors of 4 over factors of 1. So I could try a 4, I could try a negative 4, a 2, a negative 2, a 1, or a negative 1. Which one's going to work? Well, it's all pluses, so I know none of the positives are going to work. If I try a negative 1, I get negative 1 plus a negative 8 plus a negative 17 plus 4. That's not going to work. Does negative 2 work? I get negative 8 plus a negative, oh, that's an x squared, that's why. So let's try that again. Let's go back to that negative 1. Negative 1 cubed is negative 1 plus 8 minus 17 plus 4. Yeah, it doesn't work. Let's try negative 2. Negative 2 cubed is negative 8 plus negative 2 squared is, why am I blanking? Negative 2 squared is 4. 4 times 8 is 32. Negative 2 times 17 is negative 34 plus 4. That doesn't work. Let's try negative 4. Yeah, negative 4 works. So x plus 4 is a factor, negative 4 is a solution. So let's try negative 4 in synthetic division. 1, 8, 17, 4. If I drop 1, I get negative 4, which gives me 4. Negative 16 gives me 1. Negative 4, 0. So I'm left with x squared plus 4x plus 1. And that is not pretty, so we have to use the quadratic formula. So we get opposite of b plus or minus b squared minus 4ac all over 2a. So I'm going to get negative 2 plus or minus, so one's going to be plus, one's going to be minus. 16 minus 4 square root of 12. Square root of 12 over 2. Square root of 12 is 2, 2, 3. And that's going to go down to a square root of 3. This one was a doozy. Okay, so this didn't factor, so we had to use a rational root theorem or rational zero test. 2 worked. We used synthetic division to get down to a cubic. We figured out that negative 4 worked to get down to a quadratic. That didn't factor, so we had to use quadratic formula. So we have 2, we actually have 4 intercepts, but 2 are rational, okay? Now the last part of the video is, what if you're given a 0? Can you work backwards and find the polynomial? One quick thing here is complex 0 occur in conjugate pairs. So an example is up here, where we had x squared plus 3. If you were to solve, when we did that, we said x squared equaled negative 3. And then when we took the square root of both sides, we noticed that when we get solutions with I, we'll always get a positive and a negative. So if an example tells you a solution is 3i, then you know that another solution has to be negative 3i. Complex zeros or solutions occur in conjugate pairs, positives and negatives. All right, so let's try these two. It says I have a 4th degree polynomial, so I have 4 solutions. I just went in a different order because I didn't see it. And if x is 0, then you could do x minus 0 if you wanted. That doesn't make any sense. but x minus 0 is just x. So x times x plus 2 times x plus 4 times x plus 3. Now I could FOIL here and get x squared plus 7x plus 12. I could distribute here and get x squared plus 2x. Then I'd have to keep distributing. I'd get x to the 4th plus 7x cubed plus 12x squared. Then I'm going to get 2x cubed, 14x squared, plus 24x. When I clean that up, I'm going to get x to the 4th, 9x cubed, 26x squared, plus 24x. Okay. But it's telling me if I put 1 in, I get 72. So if I put 1 in, what do I get? Well, 1 to the 4th plus 9 1 cubed plus 26 1 squared plus 24 times 1. When I get 60. Let's try this again. Oh, I have a Zoom call. So hold on, I'll be back.